This problem and all other data structure problems can be found here at Sarai Studies. Link is in the description box below. I don't even read the problem. I just see hash table and I look for the method. Is going to be separate chaining or is it going to be linear probing? It's separate chaining. Okay, so then what I do is I look for m. M is always the size of my table. So it says that the initial size is 3. They don't tell you that it's m, but that's what you should realize. M is 3. What does that tell you? Literally make a table, split it into 3 boxes. So 1, 2, and 3, and you start counting at 0. So 0, 1, 2. So let's get some vocab straight. These are your keys. These are your hashes. For every key, you need to find its hash and put it in its little row here as a chain. The idea is that it's called separate chaining because it's a chain of keys. They're chained together. That's one thing. The other thing we have to worry about is, well, then how do we find the hash? They give us a function. It says to find the hash of any key. So let's say I want to find the hash for 14. I would plug in 14 here, and it tells me, hey, take 14 divided by m. M is the size of your table. That's 3. And then its remainder, that is your hash. So let's try it out for the first one. So I'm going to go ahead and take this, paste it down here, move this over here. So for 14, 3, 14, so 4, 12, 2. So what this tells me is that I'm going to put 14 in 2 because 2 is my hash for 14. So I did 14 divided by 3, the remainder was 2. It's not the answer, it's not the quotient, it's the remainder that we're talking about. So that means 14 goes here. So that's our first one. But before we continue doing that, I just wanted to mention there's one thing you have to keep in mind. They tell you that you do have to rehash. Rehash means that there's a certain point that they determine when it's like too full, and then you have to resize, and then they also have to tell you how much to resize. In this case, they tell us to double the size, but then the question is, when do we rehash? And that's determined by the load factor is 2. So they don't tell you this here, but a fact that you should know is that the load factor is really n by m. N is the number of keys in your hash table. Right now, n is 1 because there's only 1 key in my hash table. And m is the size. So it's 3, and right now n is 1. The idea is that they tell you that it's 2. That's when you resize, when this is greater than or equal to 2. So I know it says larger than 2, but equal, okay? If this is 3, in order for you to get 2, it has to be 6. So in other words, you resize every time you have double the amount of keys that you do boxes, that you do hashes. So once I have 6 items, then I will resize and make it double. Then you realize, well, that's going to be 1, 2, 3, 4, 5, 6. So after this one, you're going to resize. And then you're also going to rehash. Rehashing means that you're going to do this all again. Why? Because you have a new m. M is the size of your table. So once you resize, you're going to have a new size. It's going to be 6 now. And so then you would have to recalculate everything relative to the new size. For 8, 3, 2, 2, 2, 6. 6, 7, 8, 2. So we have 2 again. That means that the hash for 8 is 2. So we go to 2, and here's the thing. It says keys are inserted at the front of the list. What this means is you're going to have 8. You're going to have a little arrow there, and you want to insert this from the front. So this is the front. You're pushing 14 to the side so that you can insert 8. That's what's going on. And now you notice that it's forming a linked, that's why it's called separate chaining method, because you're chaining these keys together. So 27 now. 3, 27, that's 9. 27, 0. Now we have 0. So 27's hash is 0. That means you're going to go where 0 is, and you're going to plug in 27. Now let's do 10. So 3, 10, 3, 9, 1. So this is 1. That means the hash for 10 is 1. So where you see 1, you're going to plug in 10. Then we do 15. So now it's 3, 15, that's 5, 15, that's 0. So we have 0 again. That's 0. You want to do 15, you want to insert that, you insert it at the front. So you want to go to 0, push it. Push the 27 so that you can be at the front. And then finally, 90. So 3, 90, that'd be 30, 90, 0 again. You have 90 and you are inserting at the front of the list. So push it. Everything has to be pushed so that you can be at the front. And then after we add 90, we are going to resize. Why? What's the number of keys that we have? We have 1, 2, 3, 4, 5, 6. 6, right? What's the size of our array? 3. 1, 2, 3 boxes. 3. 6 divided by 3 is 2. So your load factor is 2. That means you have to double the table size. So once it's 2, because it is 2 after you insert 6, we don't do it before, right? We don't do it after we insert 15, because at 15, it's 5 out of 3, and that's not 2, right? That's still less than. So we only do it once we hit 2, and that is after we add the 6th item. In other words, just think about it in this case, it's literally once you have double the amount of boxes that you have, the amount of hashes. So then, what do? Well, we double the size. They tell us to double the size. So now we have double, literally. So now it's 3, 4, 5, but we have 1, 2, 3, 4, 5, 6 boxes. So now our is 6. And they tell us to do rehashing. In some problems, they tell us don't do rehashing and just continue on. But in this problem, they do tell us to do rehashing. So what that means for us is that we have to redo everything. And that makes sense intuitively, because we now have a new size and we organize this based on the old size. And so we kind of want to redo it again and see where these would fit based on the new size, which is 6. So then the question becomes, what order do we rehash in? Because you might be like, okay, I'm just going to do it again. I'm just going to start with 14 and do 6 into 14 and blah, blah, blah. But actually, no, that's not how you rehash, unfortunately. You actually have to start with the ones that you have already in your table in that order. So kind of like level order, the way that we did binary trees, absolutely not related, but just like, if that helps you understand, is you're going row by row. When you end, you go to the next row, and then when you end, you go to the next row. So I'm just going to kind of do the same thing I did here, but I'm going to do 90, 15, right? 90, 15, 27, then 10, and then 8, and then 14. And then I'm going to do the same process, but with these numbers in that order. And we can erase these, because rehashing means we're literally doing this again. And we can erase all of this as well. But make sure you don't erase this. Like, keep track of the fact that you haven't hashed these numbers at all. So let's rehash these given the new size. So 90 comes first. So that's my key. I want to find the hash of 90. So that literally is your key, mod m. M is 6 now. And we know that this is a fancy way of saying, hey, take 90 divided by 6, and instead of giving me the quotient, the actual answer, give me the remainder. So we're going to take 690. This is 1, 6, 79, 30, and then 5, 30, 0. So 0 here is our remainder. So that means that the hash for 90 is equal to 0. So that means I'm going to insert 90 here at 0. Then we're going to do the same for 15. So 6, 15, and that's going to be 2, and that's 12, and that's 3, and that is your remainder. So this is going to be here at 3, so we're going to insert 15 right there at 3. And then 6 into 27, that is 4, 24, 4, 5, 6, 7, 3, and again we have 3, so 27 is going to go in 3. Okay, so this is what's going to happen. We insert at the front of the list. So front is over here at the front. So we're going to have to push 15, move it over so that 27 can slide through there, just like that. Then we do 10. So 6, 10, 1, 6, 4. So let's do 4. So 4. So there's 4 there. That means that 10 is going to go right in there. And then, let's see. We do this 6, 8. That's 1, 6, 7, 8, 2. 8 is going to be pushed in there. And then 14, 2, 12, 2 again. So that's 2. So 14 is going to be pushed. So we have 14, and we are literally pushing it in from the front. So we have to push 8, move it over. It's being pushed over by 14 so that 14 can enter from the front. So what we had before we did all of this was our hash table before we rehash. But what they're referring to showing your hash table after rehashing, they don't mean this. They actually mean finish the whole thing, and then that's your answer. So that just literally means like start with where you left off, 11, and then do your thing, but with is 6 now. And by the way, how did I know that I didn't have to worry about resizing while I was like rehashing? Because rehashing is what we do as a response to resizing. That means that there's already space. There will be enough space for you to fit all of these. And so before you start rehashing, you kind of want to figure out what's your new thing. So that would be 6 at the bottom. And in order for this to be 2, well, then now that would have to be 12, right? You just like keep doubling. So now once you have 12 keys, then you resize. But clearly this was only 1, 2, 3, 4, 5, 6 keys, right? So we did not have to resize. So, but keep in mind, how many keys do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. So we're not resizing ever again because we're never going to get to 12. So yeah, we're good. We don't have to worry about resizing again. We just have to finish this off. So I need to find the hash for 11. So key is 11. M is now 6. So again, we're just doing 6 by 11. That's 1, 6, 7, 8, 9, 10, 11. That's 5. That means 11 goes here. Then 6, 7, 1, 6, 1. So 1 we haven't used. That's 1. So 7 goes right there. And now 12. So we go and do 6, 12, 2, 12, 0. So the hash for 12 is 0. So that means we have 12 and we need to add it in from the front. So from the front means we need to push 90. So we push 90, have 12 be over here. Great, that's that. And then finally 17, I ran out of space, so I'll do it over here. 6, 17, that'd be 2, so 12, and then 5. So the hash for 17 is 5. So that's going to be 17, and we insert from the front of the list. So from the front of the list, we insert, meaning we need to push 11. This goes here, this goes here. And this is your answer. This is your table after rehashing. Now, just for funsies, let's answer this question. What is the running time, big O, for rehashing given the input size n? Give the reasoning. Well, think about this. Running time is really like, how many operations are we doing when we rehash? Well, when we rehash, we are legit rehashing every single one of the keys that are in the table. So if there's n number of keys in the table, then our big O is literally O of n. Because, again, we are rehashing, well, let me say, because if there are n number of keys in the hash table, we will have to rehash each of those keys. So this is your after rehashing, and this is before rehashing, just like we had it before. And that's it for this video. I'll see you in the next.